Electromagnetic induction, this is a transformer. A transformer consists of the two coils of a wire, which are wound on a metal core. Figure 10.1 represent the transformer. State the name of a metal from which the core is made. So which material the core is made?
Iron trioxide. Iron sulfide.
The primary coil of a transformer is connected to the output of AC generator, which supplies alternating current. Explain why there is a voltage between the terminals of the secondary. So here you have 3 marks.
Because of magnetic.
They said,
All those 3 points.
yeah, all the 3 points. We have a AC supply. We connected this to a AC supply or alternating current generator. AC input produce a variable magnetic field which magnetize the iron core. And because of a change in magnetic field of an iron core, it will produce a current in the secondary, which can be step up or step down by using a suitable turn ratio.
Okay.
Like this is additional, it's not part of the answer. So AC input produces a variable magnetic field which magnetizes this iron. When this iron behaves like a magnet, the iron magnetic field is changing. As a result, it will induce EMF in the secondary. AC input produces a variable magnetic field.
Variable.
Yeah, variable means changing. Write in your own words, don't try to copy. AC input produce variable magnetic field, magnetize the iron core. Magnetize the iron core. And the changing magnetic field induce current. Changing magnetic field of the iron produce current in the secondary coil or produce a voltage in the secondary coil. So there are 560 turns in the primary. This is NP. There are 900 turns in the secondary. So this is NS. The voltage between the terminal of the secondary is 78. So this is a VS. We need the current, calculate the voltage supplied by the AC generator. We need the input here. We have 560 turns in the primary, we called NP. We have 910 secondary turns, NS. And the voltage between the two terminals of the secondary means the output voltage, this is VS, 78. So we use the formula VS over VP.
VS over VP.
NS over N.
VS over VP. NP over NS. Yeah.
VS over VP is equal to NS over NP.
Yeah. Wait, I'm recording the session as well. So VS over VP is equals to NS over NP. NS is the number of the turns of the secondary. NP is the number of the turns of primary. VS is a voltage of the secondary and VP is a voltage of the primary. We just substitute the values. What is VS here? VS is 78. What is VP? We don't know. What is NS? 910. Secondary. What is NP? 560. 560. Now cross multiply. So it will be 78 multiplied by 560 is equals to 910 multiplied by VP. 910 is multiplied, other side will be divided to 78 multiplied by 560 divided by 910. So voltage of the primary is equals to 48 volts. Which transformer is this? Step up or step down?
Step down.
Step up transformer.
You can clearly see, even without calculation, you can tell step up because the secondary is having 910 turns. And the primary is having 560 turns. So if the primary is having less turns, so it will be a step up transformer. So this is a transformer. How a transformer works? when you pass a current, an alternating current produces a magnetic field. So this behave like a magnet. This hole will be a magnet now. Because this magnetic field is changing, it produces a current here output or voltage output. That's a working principle of all the transformers. The transformers, yes. The transformers are used to increase the voltage. The transformers are used to increase the voltage when the electrical energy transmitted in the cable across a long. So explain why power loss in the cables are lower when the voltage is high. So when we increase the voltage, what will happen to current? Current will decrease. If the current will decrease, what will happen to the heat energy? It will reduce like less amount, produce less amount of heat energy. So smaller power is wasted. So when you write the structure of the answer by in a step-up transformer, when we increase the voltage, what happened to current? Current decreases. So decrease in a current reduces the heat loss or the power loss in the form of heat. And what is another advantage of using a low current? That we can use thin wires or cheaper pylons for that. So high voltage, this is a structure. Lower current, so power loss will be minimized. That's the 2 marks. 1 mark is for lower current, 1 mark so that the current means that less heat is produced or lost. Four 4.2 to 4.4 electricity question. Figure 5.1 shows a sphere that is negatively charged. No, on a figure, draw an arrow to indicate and the direction. Yes. This is a negative. So what?
Arrow is inward.
So if it's a negative, the electric field lines will point inward. Same question I give. Now here, the next one. A smaller uncharged sphere is suspended by a plastic thread. So there is a plastic thread and an uncharged sphere is there. We brought close to the negatively charged sphere. Figure 5.2 shows the two spheres. By drawing on the figure, indicate the distribution of the charge. What charge will be here? Positive, because unlike charges attract. What charge will be here? Negative. But remember, if you make 3 positive on one side, you should make 3 negative on the other. Because it should be equal number of the positive and negative charges. State what happened to S.
Gets closer to the BD thing.
So what will happen? It will be attracted towards the negatively charged sphere. Or move towards the negatively charged sphere. An earth wire is then touched the S. Describe what happened in the wire and state how this affects S. The earthing wire is connected to what? S. So this is S. Yeah. So this was positive. Yeah, we connect an earthing wire to S. What will happen? Yeah, negative charges or electrons will move out towards from the sphere to the earth.
The negative charges will move to the earth.
Negative charges move out from the sphere to the earth due to the difference in a potential.
Due to the potential difference.
Yes, due to potential difference or difference in the potential. Yes.
They won't give us the potential difference.
But Earth is zero potential always. Earth is considered to be zero potential. So everything is, yeah. No voltage, zero potential. Zero.
No.
Movement of the charge, yeah, movement of the charges, yes, it has some, but we consider it as zero potential.
Negative charge, electrons in negative charge or negative charge. So how will this affect us?
Which one?
Part 3.
It will move towards that.
No, how will it affect it?
It will move attracted towards. That's the effect.
Where will it attract?
Where it should move. This is a positive, this is negative. So where it should move. So when we connect an earthing wire, the earthing wire will remove the electron or the negative charges from sphere S. So overall, the sphere S will be positively charged.
How do we know that sphere S has voltage?
Because whenever there's a distribution of the charge, it will have a voltage. If there was no distribution of the charge, like let's say this was not there in the question, okay? And I connect an earthing wire. What will happen? Nothing will happen. Because this contain charges, but there's no difference of the charge. That's why there's no, this is zero potential. This is also zero potential. That's why the charges won't flow. But when we bring a negative charge rod here, so as a result, one side will be positive, one side will be negative. Now it will have a potential that is causing a charges to move. Okay. So when we bring a negative charge rod, the positive charge will be on one side, negative will be on another. Opposite charges are attracting each other, so it is attracted. Now we connect an earthing wire. When we connect an earthing wire, the negative charges will move out from the sphere S. So overall, on net positive charge will be on sphere S. So there will be a net positive charge on sphere S. The metal sphere S is an electrical conductor. The plastic thread is an insulator. Explain this difference by referring to the structure of the material. How a material can be a conductor or insulator. What is the difference?
Yeah.
So a metal sphere S is electrical conductor. What does it mean? It means it contains electrical charges or free electrons or delocalized electrons. Dimension metal sphere S.
So it has free electrons.
It has free electrons or delocalized electrons, the charge carriers inside. But the plastic thread is insulator. Why it is insulator? Because it does not have any free electrons or charges. So explain the difference by referring to the structure of the material. So metals have free electrons, where the plastic thread, why it is insulator? Because it does not have free electrons or ions.
Yes, sir.
This question here, a resistance, yes.
Because it doesn't have any free electrons, right? That question, because it doesn't have.
You have no free electrons for plastic rod.
Sir?
Yes, plastic thread.
है उसका अर्थिंग वायर वाले का और इस आंसर दिया है कि मुझे नहीं पता क्या है
अच्छा
नहीं शुरू होगा बंद नहीं होगा
But only till this point it is right. No need to mention the other.
सर हम कट लाइंस पूरी यूज करते हैं
The resistance of a 1 meter length of a wire is 76 ohm. So this here, this is a 1 meter wire. The resistance of this 1 meter wire is 7.6 ohm, the whole length, okay? The length of this wire is taped to a meter rule. Crocodile clip is connected to one end of the resistance wire, because if you see this, it will appear like a crocodile. Figure 7.1 shows a crocodile clip connected to terminal P. A second terminal Q is connected to a movable contact. So we can move this contact. We can move anywhere. Using a long length of a connecting wire, the movable contact is in contact with at the length L. The movable contact is in contact. The movable contact is placed between the points of the resistance wire. The resistance of R and the length R is there. So in this question, we have a wire. What we are doing is we are finding the relation between the resistance and the length. So one end of a wire which is at 0 meter mark and the other end of a wire is at 100 meter mark. One of the end we connect a crocodile clip. Okay, we'll connect a meter here. And the other end, we have a movable part. Like movable part means like we can move anywhere. And we will measure the voltage or the potential in this region, like how much voltage is there. That is, and if the resistance increase, the voltage will also increase. If the resistance decrease, the voltage will also decrease. That's now on a figure 7.2, sketch a graph to show how the R resistance vary when length is equals to 0. Resistance and length are directly proportional. If two quantities are directly proportional, what should be the shape of the graph? It will be a straight line. And another thing, it should start from origin because two quantities directly proportional must be a straight line and it starts from origin. And then we mark an appropriate value here. Mark appropriate value because it's a 1 meter wire. So maximum length will be 1. And what about the maximum resistance? I mentioned the length of a 1 meter wire is how much? 7.6. So when the length is equals to 1 meter, what is the resistance? The resistance is 7.6. Yes, you have to, because you mentioned mark appropriate values on the axes of the graph.
We have to mark the.
Yeah, because they mentioned in the question that when the resistance is 7.6, the length of the wire is 1 meter. And we know resistance and length are directly proportional. So it must be a straight line which is passing through origin. Draw a straight line first, and then the end point of the line, mark 1 meter and 7.6 ohm.
Sir,
Yes.
sir, like if the values are inversely proportional, how will we draw the?
If the values are inversely proportional, then the graph will be a curve and it won't touch any of the axes, neither x-axis nor y-axis. And the product will be constant.
Sir, for volume pressure, like volume.
Yeah, volume and pressure graph.
Will we draw the first one or the
Yeah.
second one?
No, if it were according to a Boyle's law, pressure and volume are inversely proportional. So if you have a pressure is there and a volume, so it will be a curve like this because they are inversely proportional. If you increase the pressure, the volume will decrease. But if resistance and length are directly proportional for a two proportional, directly proportional quantities, it must be a straight line which is passing through origin.
So why did we like draw a straight line which was increasing as the volume increased?
What?
Why didn't we draw a straight line as the volume was increasing? Like straight line going down. Like the pressure is decreasing.
So pressure is
Draw a
no.
straight line.
It's a non-linear relation. It does not change with the same value every time.
Oh.
Proportion, it's a non-linear relation. That's why it's a curve. Here, figure 7.3 shows a battery with the EMF of the 12 volts. So this is 12 volts and the length is 1 meter.
Oh yeah.
Wait.
No specific
No,
way,
but
sir.
Last question.
Last question, sir.
Let's say this.
Imagine again, it's about access point.
It's a 12 volt supply. So here we have, this is also 12.
Very carbon dioxide. There should be some oxygen. There's plant here.
Here it's a 12 volt supply. So the total voltage here will be 12. Okay. But this is connected. So the voltage will divide. Some part will have more voltage. Then if longer length will have a more voltage than the shorter one. State what is meant by electromotive force, EMF. What is the meaning of the term EMF?
Then as the resistance increases, will the voltage increase? As the
Voltage drop across the component increases. So what is meant by EMF? Electromotive force. It is the work done on unit charge. So it is work done on a unit charge to move around a closed circuit when chemical energy converted into electrical energy. So it is a work done on a unit charge when a chemical energy convert into electrical energy. What we call that as EMF. So energy exerted by the battery on a charge. How does a chemical, because in a battery, EMF is always refers to a battery, so a battery is having a chemical energy. A battery is having a chemical energy converted into electrical energy. Yeah, this is what the full definition. It's the energy which drives the charge out from the battery when the chemical energy is converting into electrical energy.
Sir, what would be the 1 mark definition for that?
It's of 2 marks, so always write 2 for 2.
What is one?
No, write the same definition every time. Definition, don't try to write definition in your own words. Try to learn them. The current in the resistance wire. How to find the current in the resistance wire? Look, this is a 12-volt supply. And this is equals to 7.6 ohm. That's the total resistance. This is the 12 volts and resistance is 7.6. We need the current. How to find the current? We have the voltage 12 and we have the resistance 7.6. So we use the formula V equals IR. So voltage is 12, current we don't know, and the resistance is 7.6. So 12 divided by 7.6. What's the answer?
1.5794.
So 1.58.
So don't we need to find the resistance for the specific?
No. The whole wire is connected to a battery. Like this is a battery and this whole wire is connected with a battery. So that's why we took a total voltage and we know the total resistance, that is 7.6. So resistance is 7.6 and the voltage across is 12. So we find the current, which is a ratio between a voltage and a resistance. So this is equals to 12 divided by 7.6 equals to 1.58 ampere.
Find like specific.
1.58 ampere, yes. So
how we find specific.
now we will do for specific. They will ask for specific as well. So when the charges will move, 1.58 ampere of a current will flow through this component. The next is the potential between P and Q when a length is 0.35. Look, the voltage and the resistance are directly proportional and voltage and the length also is directly proportional. When the voltage is 12, how much is the length? What is the total length? 1 meter. When the length of a 1 meter, it was having a voltage of 12. We want to find the potential when the length is 0.35. So if the length is 0.35 here, this is 0.35. So if the length is 0.35, how much is the voltage X? Just cross multiply. 12 multiplied by X, the 12 multiplied by 0.35. So what we'll get? We'll get 4.2 volts. So means the voltage here will be equals to 4.2 volts. So we have, whenever we have a resistance wire, if we have a resistance wire, this wire was having a total voltage of 12 and it was having a length of 1 meter. Now the length is 0.35 ampere. It's 0.35 meter. What is the voltage here? So resistance and length are directly proportional. Same thing, resistance, voltage and length are also directly proportional. So for a 12 volt was having, for a 1 meter length, it was total potential of 12. So for a 0.35 meter length, what is the total potential? X. We just cross multiply. So when we cross multiply, we'll get 4.2 volts.
Voltage and length is that.
Voltage and length are directly proportional. Voltage and resistance are directly proportional.
Current is-
Current is inversely proportional. The charge that passes through the resistor in 5.5 minutes. Yeah. The charge that passes through a resistance in 5.5 minutes. If you need the charge, the current was 1.58 ampere. This was 4.2 volts. If you need the charge, the current is charge divided by time. The total current in the circuit is 1.58. The charge we don't know. And the time is 5.5 minutes. So we have to convert into second. So 5.5 multiplied by 60. This whole will be multiplied 1.58 multiplied by 5.5 multiplied by 60. What is the total charge?
521.4.
521.4 coulomb. 1.58 multiplied by 5.5 multiplied by 60. So 521 coulomb we can say. That's will be the total charge which will flow.
So 5